little bit out of 2.6 and 2.7. 2.6 and 2.7 are kind of combined together. I usually teach 2.7 before I teach 2.6 because you need that before you go on and do the other one. So we're just going to look now quickly at how to graph these nonlinear functions, because we do need this for 2.6, and we'll review that. When we go to graph things that are not lines, we have basic graphs in the back cover of our textbook here. So as you can see, they're not lines. The first one is the identity, and that's what we covered in previous sections. We covered how to graph lines. So we already covered that. Today we're going to go over again quickly what we did last week with how to graph these nonlinear functions. So we'll do several examples of each one. Then we'll finish up 2.6, and then we'll try to finish up 2.8 this evening as well. So again, we're doing 2.7 before we do 2.6 because I think they should have been covered in the opposite order. But let's learn how to graph some of these nonlinear functions. So we'll start with a very basic one. And what we're going to do here is we're going to try and graph this. So let's try and graph f of x equals 5x squared. So this is what we're going to be looking at. Now, this is not a line anymore. And when we go to graph this, it's not going to be a line. It's going to be a curve. And how do we determine what curve it is? Well, we look at the operation on the x. And in this case, what operation is on the x? It's a square. So then we go to the back cover of our textbook, and we find the graph that matches up with our operation. And they're all labeled. You got the square, the cube, the square root, the cube root, absolute value, and the greatest integer. So ours is the square, so we're going to have a squaring function. And the graph of a squaring function is a u. So our basic graph, and I usually sketch these over to the side, our basic graph is just a u like that. Now, what's happening with ours? Well, we have that 5 in front. And that 5 in front is like the slope. So that 5 is going to be very similar to your slope. We look at our picture, and it needs to make a U. We're not moving it up or down any, and we're not moving it left or right either. So if we don't move it up or down, or left or right, then we start here at 0, 0. And from that 0, 0, we're going to use that 5, and we're going to make that a 5 over 1. So we're going to go up 5 and over 1. So we started our 0, 0, and we go up 5. So 1, 2, 3, 4, 5. So that's 5 up and 1 over. We make our dot. Now when we connect these together, we're going to be connecting them together, but not with a straight line. We're going to connect them together with a curve. Now we only have half of it. We know our graph needs to look like what? It needs to look like this. So if we have half of it, how do we get the other side? Well, what we do to get the other side is we go up 5 and we go back 1. And when we connect the other side together, that makes our U. Now, what happened to our graph? Well, when we work with this squaring function, normally it's like this. Okay, so it's a pretty wide curve. Now, what did that 5 in front do? Well, that 5 shrank it up like this. So that 5 made it 5 times as narrow. So it went from the original function like this to more like that. So that makes it 5 times as narrow. Let's try another one. Let's try and graph an absolute value. Let's try and graph f of x equals minus 1/2 the absolute value of x. So when we go to graph this, the first thing we do is we realize it's not going to be a line anymore, and we go to the back cover of our textbook and we find the absolute value graph. And the absolute value graph looks like a V. So that's where we're going to begin. What's going to happen to ours is it's going to be upside down. So the quick sketch of our graph over here looks like this. So that's the very basic one. Now, what does ours look like? Well, ours is going to be upside down because it's negative. And again, that 1/2, well, that's like the slope. But it must be over 1. So what we're going to do is we're going to look at our function. We know it's an absolute value. We know it has to be a V. We're not adjusting it up or down or left or right. The next one we will, though. This one we're going to start here at 0, 0. Now, again, we cannot go down 1 and over 2 because that's going to distort the graph. When we go to graph nonlinear functions, we have to make that over 1. So we'll take that minus 1/2 and we'll make that minus 1/2 over 1. So if it's a fraction, it has to be over 1. It's a negative, so that means we go down 1/2 and over 1. So we'll go down about 1/2, and then we're going to go over 1, and we'll make our dot. So we went down about 1/2, over about 1. Now we need to connect them together to make a V. So that's our goal. It needs to look like this. It's not curved, it's a V. So there's half of it. Okay. Is everyone okay with that part? Now, what do we know it needs to look like? It needs to look like this. Ours is upside down. Why? Because it's negative. So that flips it over. Just like the slope, it goes the opposite direction. So it goes up, it goes down from left to right. This is going to invert that graph. So we have half of it. How do we get the other side? Well, we go down about 1/2 and back about 1. And then we can connect it together to get the other side. Find a better marker. Okay, so then we'll connect them together. And it looks about like that. And so what happened to our graph? Well, our graph should be a V. So it should look like this. But what happened to ours? Ours is upside down, and that 1/2 is less than 1, so it's going to widen it about twice as much. So it's going to be an upside down V and a little bit wider. It's upside down because of that negative. And so that's why it's inverted. We have not been moving the graphs up or down yet. So we'll go ahead and do that next. When we move things up and down, we do that by adding or subtracting a number on the end. So let's try and graph this one. So I want you to graph this. Now this is a cube. So again, what do? We go to the back cover of our textbook And you don't have to memorize these graphs. When we come to our final, you'll see some of these questions, and you can use the back cover of your textbook, so you don't have to memorize them. Now, we are looking at a cube, so a cube looks like this. So that's what it needs to look like. So let's draw our cube over here. So we know our basic graph looks similar to that. So that's what our end result should look like, something like that. Then we look at our function here. Now this -5, that is your y-intercept. So that means we have to move the graph down 5 units. That 4 again, that's going to be like the slope. It's not the slope because slope only works for linear functions, but it's similar to that. Okay, so now we go ahead and we're not going to start at 0, 0. We're going to start at what? Down 5 units. So we're going to start at 0, -5. So that's where we're going to start at. Now our graph needs to look like this. What do we use? That 4. So we start at that 0, -5, and we're going to have to go up 4 units and then over 1 unit. So we'll go up 4 and then over 1. Make your dot, and we need to connect them together with a curve, just like this. It's going to give us this picture right here. How do we get the other side? Because it needs to make an S type of shape like this. How do we get the other side? We go back to our starting point, which is that -0, -5, and we've got to go down 4, back 1. That'll make it curve like it's supposed to. So we go back to our point here. We're not going to go up because if we went up, see, it'd make it look like a U, and ours is not a U, it's like this. So we go back to our starting point, that -5, and we're going to go down 4. So we're going to have to go down 4 units, and then back 1 unit. And that's going to make our second dot right there. And then we connect it together, and it makes our curve like that. So what happened to our graph? Well, our original graph is this, correct? Okay. And what did we do? The -5 moved it down 5 units. And then what about that 4 in front? It's positive, so it stays the same. But what did that do to the graph? It made it 4 times as compressed, because normally it would be a lot wider. Like this one's a lot wider. It's just smaller, but it would be a lot wider. This one's very narrow because of the 4. So numbers on the end are going to move it up and down. Positives go up, negatives go down. We'll look at a couple more. And then we'll talk about, review all the different operations, how it works with functions, what moves it up and down, what moves it left and right, and everything else. So let's do another one of these, and then we'll talk about how to move it left and right. So let's try and graph -1/2 the square root of x plus 3. So again, first things first, back cover of our textbook. What's the graph look like? Square root. So it looks like that. And so all I have to do is figure out which one it looks like. So the basic function is right there. So there's our basic graph. Now, what's going to happen to everything? And I always like to start at the end. So that 3 on the end, it's positive, so it moves it up. And that 1/2 is there, and it's a negative. So that means we're going to start up 3 units. So instead of at 0, 0, we're going to start at 0, 3. Now, that 1/2, what do we have to do with that? Well, we have to write it over 1. Has to be over 1, otherwise your graph will look distorted. Because if you go down 1 over 2, it's going to be way too wide, because these aren't lines anymore. So we go down about 1/2 and over 1. And again, these are just approximations, so we don't have to be perfect. But we go down about 1/2 a unit, and then we go over about 1 unit. And then we connect them together with a curve. Ours is upside down. Why is ours upside down? Because of the negative in front. So there's what your graph will look like. So it's opposite of that one up there because of the negative, so it flipped over, and we moved it up 3 units. So now let's review what we've covered. When we go to graph functions, what have we learned so far? When we go to graph these functions, the number in front of the x is like the slope. It's not the slope, but it's like the slope. And it must be over 1. So it has to be over 1. So numbers in front of that x are going to behave like the slope, and must be over 1. Now, what else have we learned so far? Well, we've learned that numbers on the end move it up and down. So numbers on the end, if they're positive, that moves it up. If they're negative, it moves it down. So that's what we've learned so far. Now we're going to learn how to move things left and right. Make that a little bit too right there. So we're now going to learn how to move things left to right. And numbers inside the operation, so for example, inside the absolute value, underneath the square root, inside of a square, those move it left to right. So numbers inside the operation, if they are positive, they move it back. It's opposite of what you think it should do. So if it's inside that operation, it's going to move it back, and it's positive. If it's negative, it moves it forward to the right. So it's opposite of what you think it would do. So the number in front, that behaves like the slope. Numbers on the end, vertically move it up and down. Numbers inside the operation are horizontal. They move it left to right. And that's what we're going to be looking at next. So we'll do a couple of these where we move it up, down, and left and right. This is going to cover all of our translations. Then we'll talk about the greatest integer function, and then we'll move on to the new material in 2.6 today. So let's look at 2 more of these. So we're going to try and graph f of x equals, how about minus parentheses x plus 4 quantity squared minus 2. So this one's got several things going on. If there's no number in front, we know that's going to be a 1. So this is actually a negative 1. We don't normally write the 1 there, but if you want to, you go ahead and put the 1. So you realize that is like your slope. What about the negative 2? I always like to start on the end. That negative 2 is on the end. Negatives on the end, move it down. The 4 is inside the operation. And if it's inside the operation, inside parentheses, underneath roots, inside absolute value bars, those again move it horizontally. It's positive, so it moves it back 4 units, because you're actually setting that to 0. Now, with all of this in mind, we're not going to start at 0, 0. We're going to now start at negative 4, because we're moving it back 4 units, negative 2. So that is where we're going to start. Okay, so we're going to move it back 4, down 2. Remember, this is your x, and this is your y. Students still sometimes get the x and the y mixed up, but we're moving it back 4, down 2. Now, what's the basic shape? This is a square, so the basic shape is that. Now, what about r's? Well, that negative 1 in front, what is that going to do to my picture? It's going to flip it over, right? So we're going to have a u. It's going down. We're not going to start at 0, 0. We're going to start right here at negative 4, negative 2. So this is where we're going to start. Very important you know where to start. And we're going to start right here at negative 4, negative 2. Now, what are we going to do? We're going to go down 1, over 1. So we go down 1, over 1, make our dot. Just went down 1, over 1. We need it to make a U, so we curve them together. Don't use a straight line, use a little bit of a curve. Now we do the same process to get the other half of that U. So we go down 1, and then we go back 1. We make our new dot right there, connect it together, and there is your finished graph. So what did we do? We moved the graph down 2, we moved it back to the left 4, we flipped it upside down because of that negative 1. We'll do one more of these, and then we'll look at the greatest integer. So we'll do one more of these, and then we'll look at the greatest integer. So let's try and graph. Now, it doesn't have to be f of x. It can be a different function. How about we try and graph h of x equals 3 times the cube root of x minus 5 plus 1. And that's a cube root. So when we go to the back cover of our textbook, we always do that first. We identify the fact that this is a cube root, so it needs to look like that. Is everyone okay with how to find those? So we look at what it is. It's a cube root, so that means it's going to be that picture. So our picture, kind of our guide, is this. And if you take a calculus course, you'll learn a lot more about graphing. All we're covering in this class is the very basics. You take a college calculus course, you will cover in detail all the different translations and how they work. We are only looking at the very, very basics. So what's going to happen? Well, when we look at this, I always like to start at the end. And this 1 on the end, it's positive. So that's going to move it up, 1. The 5 is underneath that cube root, and it's negative. opposite of what you think it should do. So that's going to move it forward 5. So identify where we start. In this case, we start at 5, 1. So we're going to start here at 5, 1. And 5, 1 would be over 5. And up 1, which is right here. Now, what number's in front? Well, that 3 is in front. Don't get that cube mixed up with the 3. They're separate. So that 3 is in front there because it's a cube root, but that goes with the root, but that 3 is in front. So what does that tell us then? That tells us we go up 3 over 1. So from our starting point, we go up 3. So we're going to have to go up about 3 units and over about 1 unit. We'll make our curve here. And then what about the other side? Well, we need to look like this. So we go back to our starting point. And what do? We go down 3. So 1, 2, 3 units down. And you've got a grid, so it'll be a lot easier for you to graph these than for me. And then we go over about 1, make our new dot, and we connect it together. And there's your picture. Okay, so what happened? We slid the graph up 1 unit. We slid the graph to the right 5, and then that 3 in this case made it 3 times as tall because it's on its side, so it's 3 times taller than the other one. The only one we haven't covered yet is the greatest integer. So we're now going to talk about the greatest integer. And the greatest integer is sometimes called the stairs. And this is actually in 2.6. Okay, it's called the floor. Sorry about that, not the stairs. But it looks like a case of stairs, but it's called the floor because you round down. And this is the greatest integer graph. And these kind of look like absolute value bars, but they're not. Okay, they're greatest integer bars. They're kind of hard to draw, but these are greatest integer bars. And the graph of the greatest integer bars here looks like this. Looks like a case of stairs. I call it kind of the stair function here. And if you go on and you take a physical science course and you look at graphs, you may also encounter the least integer. But this is the greatest integer, and what it's doing is it's rounding down. Now, there are plenty of examples of this kind of function that we use every day. The most common one is if we go to Redbox and we rent a DVD. Okay, now we rent that DVD. Okay, if I return that DVD early that day, do I get my money back? No, I don't get any money back at all, do I? Right, I've already been charged that fee. So what happens then if I rent that DVD and I don't bring it back that day? Then I'm charged a late fee and I go up to the next level. And then if I do that again, if I don't bring it back the next day, what happens? You charge that same fee. Doesn't matter when you bring it back that day, but if you don't bring it back, what happens? It goes up to the next level, and so on. And if you bring it back early that day, it doesn't matter because you charge the same fee. But once you pass that time frame, you go up to the next level. Post office does this as well for zip codes, depending upon what a package weighs and where it goes. Zip codes are done like this because it's okay, if it's in this group of zip codes, you charge this amount. If it's in this group, the next amount, and so on. So the greatest integer looks like a case of stairs. And when we go to graph these, we always start with a closed circle. And they graph just like all the others. And I'll put a 2 in front of it. So let's go ahead and graph this one. I don't know, a lot of times students get these confused. These are not absolute value bars. These are greatest integer bars. Some textbooks call it the floor. And if you take a physical science class or a physics course and you look at things with the greatest integer, they might call it the floor. Least integer is the ceiling. But we don't even look at the least integer. We only focus on the greatest integer. So is there a number on the end? No. So we're not going to move the graph up or down any. But what about this -3? Well, this -3 is inside the bars. So since it's negative and it's inside the bars, it's opposite of what you think it should do. So that's going to move it forward 3 units. And what about the 2? Well, that controls the height of the stairs. We know since it's the greatest integer, it should look like a case of stairs. So the basic graph is this. Where are we going to have to start at? We're going to start forward 3 units, and we're not going up or down any. So that's going to be started at now 3, 0. So we're going to start it at 3, 0. So that's going to be forward now 3 units. And we always start with a closed circle. Now, what's in front? 2 over 1. So what do? Up 2 and over 1. So from our starting point, at that 3, 0, what do? We go up 2 over 1 and we make a dot. Then we go up again, up 2, from that second dot, over 1, make a dot. And now we connect them together to make our case of stairs. And we want to couple in the other direction as well. So we'll go back to our starting point, and we're going to go down 2, back 1, make a dot, down 2, back 1, make another dot, and then there is your finished graph. So what did that 2 do in front? It made the stairs twice as tall. If it would have been a 5, they'd be 5 times as tall. And if it was a half, they'd be a half as tall. What did that -3 do? Moved it forward 3 units. We'll do one more of these, and then we're going to look at the rest of 2, 6. So we'll graph one more of these greatest integer functions. Okay, so we know again, it looks like a case of stairs. So our graph is going to look similar to this. Just a quick sketch over the side. I always do that so I know what it looks like. That way I know what my result should be. So it should look something like that. That -4 is on the end. So it's on the end, so that brings it down 4 units. And that's going to make our case of stairs, instead of going up from left to right, down from left to right, because it's negative. So where do we start at? Well, we're going to start now at 0, comma, -4. And you always start with a closed circle. What's that 2 going to do in front? It's negative, so that means we go down 2, back 1. So you start from your closed circle. Now you go down 2, back 1, make a dot. Down 2, forward 1, make a dot. And you can make as many as you want. You want 2 or 3 of them. And then you connect them together with the closed circles. And we want a couple in the other direction. So we'll go back to our 0, -4, and want it over here. So we're going to have to go up 2, over 1. So up 2, over 1, make a dot. Up 2, over 1, make a dot. And now you can kind of see what the graph will look like. So it should be a case of stairs. And instead of going up from left to right, like this one is, this one goes down from left to right. And it's going to be down 4 units. So that's kind of the basics of what we covered last class. That was a quick review. There are some things we didn't cover, but you can go back and look at the video notes or the video lecture from last time if you need to. But that's just kind of a quick overview. We didn't cover every bit of it, but we covered enough. So we can now look at and finish up 2.6. So most of that was 2.7. The greatest integers are in 2.6. And again, I wish they would have switched them around and did them the opposite way, but it's fine. So we're going to now look at 2.6 some more. That greatest integers were in 2.6. The other was in 2.7. But we're going to now look at piecewise defined functions. And so we're now going to look at what are called piecewise defined functions. And piecewise defined functions, just like the name states, are going to be done in pieces. So we're going to be looking now at functions, and there's multiple parts to these, but they have to be done in pieces. I'm going to give you one of them, and we're going to evaluate it. And once we've evaluated 2 of these, we'll take a break, we'll come back, and we'll learn how to graph them. So we're going to look at a piecewise defined function. And here's your given function. Let's say f of x, and this is going to be have 2 rows in it. F of x is 2x minus 3 if x is, let's say, less than -1. And how about x squared if x is greater than or equal to -1. So see, it's got 2 rows here. Now, what falls into each row? Well, I'm going to call this row 1 and this row 2. Now, row 1 is going to be for values of x that are less than a -1. The second row is greater than or equal to -1. So when we look at these to figure out which function it falls into, we have to first look at our x value. And in this case, if it's less than -1, it goes in the first one. If it's bigger than or equal to a -1, it goes in the second one. So I'm going to have you evaluate these down using that function. So let's look at, how about f of 4? We'll work with that one. About f of negative 3. Let's do f of 0. And one more. Let's look at f of negative 1. And we're going to be using this function here. Now, we need to first figure out for each of these which row they go into. This 4 is your x value. So each of these has that x value. Now, what do we know about 4? Is 4 less than a negative 1? No. Is 4 bigger than a negative 1? Yes. So which row are we going to use? We're going to use the second row because it's bigger than negative 1. What about the next one, f of negative 3? Well, that's less than a negative 1, so that means we use row 1. What about 0? 0 is bigger than negative 1, so that means we use row 2, right? Because row 2 is for values of x that are bigger than a negative 1. And what about negative 1 itself? Well, it has an equal bar on this one, so we're going to be using row number 2. So do you see how I figured out which row it falls under? I looked at my values. So 4. 4 is clearly bigger than negative 1, so it's 2. Negative 3 is smaller than that negative 1, so it's row 1. 0 is still bigger than negative 1, so it's row 2. And negative 1 itself, we look at where the equal bar is, and it's in row 2, so that's what we're going to be using. Now we're going to plug our values in and find the answer. So the first one was f of 4, and we're going to be using row 2. So what would that be if we used row 2? Well, what's our function? X squared. So we're going to take that 4 and we're going to square it, and that would give you then 16. Because row 2 says you square the number. What about negative 3? Well, negative 3 is in row 1. And that is 2x minus 3. So what would that be if I plug my 3 in? That negative 3 in, that would be 2 times a minus 3, which breaks down then to give you what? To give you negative 9. What about 0? 0's in row 2 again. And row 2 is simply x squared. So that would be 0 squared, which is then what? Simple enough, 0. And what about f of negative 1? Well, f of negative 1, again, we know because the equals falls under row 2. And so f of negative 1 would be negative 1 squared, which is then 1. So that's how you evaluate them down. We're going to do one more of these, then we'll take a short break. This one's going to have 3 rows. So here's going to be your function again. Now this one has 3 rows in it. And this is going to be if x is, let's say, less than or equal to 0. This one will be if x is between 0 and 4. And the last one will be if x is greater than or equal to 4. And we've got our 3 rows here in this case. The most you're ever going to have is 3. You can have more, but in this class we only look at 3 of them. So now I want you to find the following. Let's try to find f of 2. How about f of 5? Let's do f of 0 and f of negative 3. Okay, so what do we know about each row? Let's talk about row 1 here. What's the conditions for row 1? The conditions for row 1 are numbers that are less than 0, right? Less than or equal to 0, row 1. Row 2 is for numbers greater than 0, yet less than 4. And the third row is for your values of x that are bigger than 4. So you need to figure out first which row these fall under. So f of 2. Well, 2 is 2 between 0 and 4. Yes, so that's going to be row 2. What about f of 5? Well, f of 5 is bigger than 4. So that's going to be row 3. Because 5 is bigger than 4. What about 0? Look at where it's going to fall. Row 1 has the bar underneath. That means it includes 0. So that means we're going to be using row 1 here. And then f of negative 3, well, that's less than 0. So that one would also be row 1. So now I'll go ahead and work these out. And see what our values are. These are actually pretty simple once you understand the concepts. So f of 2. Well, f of 2 is in row 2. And row 2 is x minus 5. So that's 2 minus 5, which is then a minus 3. You just plug the value in to the second row. What about f of 5? We said that's for row 3. Now, look at row 3. This is a constant function. And we covered that a couple weeks ago when we looked at lines. This is a constant function. Since there's no x there at all, it's 4. So if it falls in row 3, what is it going to be? The number 4. Because there's no x attached with it. What about f of 0? Well, f of 0 is row 1. So that's 2 times 0 squared, which is then again 0. And then finally, what about f of negative 3? Well, f of negative 3, that's row 1 again. So that's 2 times a negative 3 squared, which is 2 times 9, which is then positive 18. Okay? So let's now go ahead and take a short break. And we'll meet back here at, let's say 7:50. So let's meet back here about 7:50.
You said